Today in Algebra 2, we did lesson 3.2, part 1, which was how to solve a system of equations using substitution. Just as a reminder, a system of equations is a set of two different equations with two variables. Normally we're working with x and y if we're looking at two lines, like we did when we graphed two lines, but we can have any two variables, just as we have here. So I'm going to show you with this problem, r plus s equals negative 12, and for r minus 6s equals positive 12, show you how substitution works. The first thing I'm going to do is I'm going to solve for one of my variables in terms of another. So as a reminder, what that means is I'm going to just pick one of the variables and get them by themselves on one side. So I'm just going to isolate r. So I'm going to say r equals negative 12 minus s. So what I did was I subtracted s on each side. I got r equals negative 12 minus s. So now I have something for r, right? I know what r equals. So what that means is that any time that I see an r in my second equation, I'm just going to take this negative 12 minus s and substitute it in for r. So now what I have is 4 times the quantity negative 12 minus s minus 6s equals 12. And you should see that I'm getting that equation straight from here. So now I'm going to use a distributive property, and I get negative 48 minus 4s minus 6s equals 12. I combine my like terms, and then I'm going to go ahead and isolate my variable by adding on each side. So when I divide each side by negative 10, I get s equals negative 6. So I found one of my variables. So now all I have to do is take this number and plug it back into my equation up here. Okay, so where I said r equals negative 12 minus s, that means that r equals, since I said s is negative 6, that negative 12 minus a negative 6 is equal to r. So negative 12 minus negative 6 is negative 6. So r also equals negative 6. So then my answer would be r equals negative 6 and s equals negative 6. Now if I had an equation with x and y in it, I could write my coordinates. And this is actually what we got when we graphed. We got the intersection of the 2 points, but now we just solved it using substitution instead.